Guys, this is honestly one of those moments where we can basically say that famous sentence all over again. You know the one. Houston, we have a problem. Seriously, guys, look up. I want you to look up right now, right above our heads. Most of us see a blue sky or a starry night, but there's an invisible danger up there. There are thousands, literally thousands, of metal objects screaming through space faster than a rifle bullet. And guys, let me tell you, that is not good. We could be just days away from a total, irreversible disaster. You can't see them with your eyes, you can't hear them because there is no sound in space, but I promise you, they are there. And the scary part? If just one thing goes wrong, guys, just one tiny calculation error, we might permanently lose access to space. You heard me right, access to space. Gone. Now, we've looked at space quite a bit on this channel recently, mostly because of that mysterious interstellar object or whatever the heck it is. By the way, if you missed that, the 3-body/Atlas playlist is linked in the end screen. Go check it out after this. But guys, listen to me. This isn't something that might happen in the distant future. We aren't talking about decades from now. This could happen in days. It could be happening right now while I'm recording this .so. Let's really dive deep into what I'm actually talking about here. And before we do, please do me a huge favor. Go ahead and give this video an early like and click that hype button. It really helps my channel out, and it doesn't cost you a single penny. Thank you so much, guys. I appreciate it. So let's get serious. I'm not talking about science fiction here. I'm not talking about some wild conspiracy theory on a forum. This isn't a script for a Hollywood disaster movie where the hero saves the day. This is really real. These are quantified risks, math and physics, and the scientists are now warning us loudly. They're saying that Earth's orbit, our orbit, has become a fragile house of cards. What do I mean by that? Think about it. You know how easily a house of cards can crumble? You tap the table, poof, and it's over. Pull out just one card, the wrong card, and the entire structure collapses instantly. I want to explain to you in very simple terms what this syndrome we're talking about really is. It's a specific phenomenon. It's a syndrome called the Kessler Syndrome. And why is this all of a sudden such a huge problem? You guys correct me often in the comments, asking why now? Why does it matter right this second? And how could a single event, taking out just one card from that deck, trigger a chain reaction that traps humanity on Earth for generations? Traps us, guys, like a prison. So, no going to Mars. No Elon Musk sending life to other planets. Nope, we are stuck. Here's the most disturbing part, guys. Listen closely to this. We already know exactly how close we are to this tipping point. There is now a number for it. A clock. It's like a literal doomsday clock for our satellites. And right now, well, that clock says 2.8 days. Okay, let's rewind this a bit, guys. Let's take a step back. What am I talking about? I'm not crazy. What does space really look like for us non-astronauts? Because most normal people imagine space as this vast, empty black void. But guys, it isn't empty. Not anymore. The low Earth orbit, that region just a few hundred miles or kilometers above us, is not that far away. It's closer than driving across some states. And right now, it is more like a high-speed junkyard. And high speed is the critical problem here. So, it's a junkyard of what exactly? We know there are active satellites, sure. But there are also dead satellites that nobody controls anymore. There are broken fragments from old collisions. There are old rocket stages floating around. There are even paint flakes and tiny metal shards. And despite all this trash, we are sending up more and more satellites, more than ever in human history. The whole shizzy up there, all that junk, is moving at roughly 28,000 kilometers per hour. That is roughly 20,000 miles per hour. This is insane speed. At that velocity, imagine this. A simple metal bolt the size of a coin can destroy an entire satellite instantly if it hits it. A fragment the size of a grain of sand? It hits with the force of a bowling ball. It can punch right through solid metal armor. Now, here is the key idea you have to understand. Satellites don't sit still. We know that, right? They don't hover in one spot. They race around the Earth, circling the entire planet every 90 minutes. That means they're constantly crossing paths with thousands of other objects over and over again. And recently, guys, something changed. The game changed. Let's talk about mega constellations. That is the real game changer here. Until a few years ago, space was crowded. Yes, but it was manageable. We could track things. Then came the mega constellations. Thousands upon thousands of satellites launched into nearly identical orbits. Same altitude, same traffic lanes, right? The largest example, obviously, is Starlink. I use Starlink very often. I love it, and I do have one, right? It's great tech. But don't just blame Starlink. Amazon is building its own massive fleet. China is building its own. Soon, tens of thousands more satellites will join the ones already up there. Here's what that means in practice, guys. We actually have the numbers on this. Every single 22 seconds, 2 satellites pass within 1 kilometer, like 0.7 miles, of each other. That is way too close for comfort in space. If we look at Starlink alone, close approaches happen every 11 minutes. Think about that. If that was our air travel, if planes were flying that close every 11 minutes, we would not fly anymore, would we? I certainly wouldn't get on a plane to... So what does this mean? It means each satellite must constantly dodge others. They're playing dodgeball at 20,000 miles per hour. On average, one single satellite performs more than 40 collision avoidance maneuvers per year. Now, multiply that by thousands of satellites. We have over 100,000 orbital maneuvers per year already happening, and they have to be executed perfectly without error every single time. Did you know that space has basically become air traffic control, but without pilots? It's all automated. Why is this terrifying? So far, we have to say we've been lucky. Extremely lucky. We haven't had catastrophic collisions or massive chain reactions yet. But the scary part is that the entire system depends on something extremely fragile. Perfect control, perfect communication, and perfect timing. Every second, every day, forever. And that raises the brutal question. It really is a brutal thing to ask. What happens if control is lost? Not forever, not even for a week. What if we lose control just for a short time? Let's talk about the Kessler Syndrome again. It's very important because the Kessler Syndrome isn't just a crash. It's a chain reaction. It works like this. 2 objects collide in orbit. Boom! That collision creates thousands of new fragments. Those fragments fly off like buckshot and then hit other satellites. Those impacts create even more fragments, and the process feeds itself. It becomes a runaway train. Eventually, the orbit becomes filled with so much debris that it is too dangerous to use. Think about sending a manned spacecraft up there through a cloud of bullets. You can't. So, no satellites, no launches, no space travel. That is what it really means. Think about military defense and how they use satellites for so many things. We use them on our channel now for earthquake predictions, measuring fault movements, finding microseismic earthquakes to predict volcanic eruptions. But that's just a tiny fraction of what we use satellites for, right? What about navigation? Banking? The internet? If this happens, Earth becomes surrounded by a cloud of shrapnel moving at hypersonic speed. And once that starts, I want to make this crystal clear, it cannot be stopped. How would you stop it? Are you going to send a huge vacuum cleaner up to space to collect it all? A huge magnet or something? Well, let's rewind back to the 1970s. That idea was already proposed and talked about back then. But back then, it sounded theoretical because there wasn't much stuff up there, right? But today, it's a totally different game. It doesn't look hypothetical anymore. It looks inevitable. So we have a crash clock, guys. The number that changes everything. Boof, there it is on the screen. As I always say, scientists recently introduced a new metric. Think of it as a stress test for Earth's orbit. Scientists asked a simple question. If satellite operators lost control, how long until the first major collision happens? This is called the crash clock. And here are the results, guys. And let me tell you, they are not good. In 2018, the crash clock was about 121 days. That means if everything went dark, we had months to recover, to fix the code, to reboot the systems before a crash. But I have to say, last year in 2025, the crash clock collapsed. It dropped to 2.8 days, less than 72 hours. Let that sink in for a second. This clock really tells us shiz is going to hit the fizzy if control is lost even briefly. A collision is likely in under 3 days. That is what this clock is telling us. 2.8 days. And it gets worse. If control is lost for just 24 hours, there's already a 30% chance of a collision anyway. And why? Because one collision is enough. Just one. Why is one collision all it takes? Because a single satellite collision creates thousands of fragments, and they do not disappear. There is no garbage collector coming to pick them up. They don't slow down quickly, which is also a problem. They keep their speed and stay in orbit for years, sometimes decades. Each one basically becomes a new bullet shooting through space. This is how a slow problem becomes a runaway disaster. We can call it a seed event. Once seeded, the process can continue for centuries, and that's a big problem since we are really dependent on our satellites. But we have to talk about the real danger. How could control be lost? I mean, we have AI now, supercomputers. It's not like in 1998 where programmers were told to create reliable software and just hope for the best. Look at the space shuttle. The error margin of that software was less than 3%. If I'm like 3% these days, that would be crazy, right? So, how could we possibly lose control? Guys, the answer is uncomfortable. It's not hackers. It's not a bug that it's the sun. I'm talking about solar storms. You know, I recently made a video about solar flares. Do they cause earthquakes? Do they cause volcanic eruptions? No, they don't. That is the scientific knowledge we have. Studies have looked into this. No, the sun doesn't trigger earthquakes, but up in space? When you're closer to the sun, outside the protection of our atmosphere, it has a massive effect. And solar storms are not rare. When we have strong ones, they're unpredictable. When the sun erupts, communication can fail. We know that on Earth navigation systems can glitch and electronics can be damaged. But there's another effect many people don't know about. Solar storms heat the Earth's atmosphere. Let's stay away from the climate change issue for a second, right? This is just physics. They heat the upper atmosphere. And what does that cause? That's the interesting part. It causes Earth's atmosphere to puff up. It expands upwards. So suddenly, satellites that were flying in a vacuum are now flying through thin air. They experience more drag. Their orbits shift. Their positions become uncertain. Hint, hint. If the position is uncertain, you can't dodge collisions. Can we control that? I'll give you a real-world example. In 2024, a strong solar storm forced over half of all low Earth orbit satellites to burn fuel just to stay where they were, to not be dragged down. And some were unfortunately lost entirely to, now, imagine a stronger storm. A storm that knocks out real-time tracking, command uplinks, and coordination systems. Suddenly, we have no maneuvers, no avoidance, no control, and the clock starts ticking. 2.8 days, guys. And this is not just about losing the internet, right? If the Kessler Syndrome starts, GPS fails. Weather satellites fail. Military surveillance fails. Disaster monitoring fails. Space launches become completely impossible. Humanity doesn't just lose its satellites. We lose access to space for generations. We'd have a huge problem here on Earth because we'd be going backwards in time. And the sad part? We're the ones who made this worse. The problem didn't have to be this fragile. But for example, nations have done anti-satellite weapons tests that blew things up and created massive debris clouds up in space. Old rocket stages were just left in orbit to rot. Disposal rules were really weak. Enforcement was basically minimal. Even now, fines are rare, rules are inconsistent, and cleanup is almost non-existent. New policies help, sure, but they don't solve the core issue. Because if control is lost, rules don't matter anymore. Physics takes over. How can I name what I'm about to tell you? Probably the uncomfortable conclusion. We have built something powerful, yes. It's very useful and has brought us ahead a lot. Global internet, global coverage, global connectivity. It's amazing, but we built it on a knife's edge. I really have to say, this is a system that must work perfectly all the time. No exceptions, with no margin for failure. And this is why I said uncomfortable conclusion. Scientists are now telling us we are no longer talking about decades. We're talking about days, point one storm, one failure, one collision, and the door to space slams shut. Over and out. So the question is no longer, could the Kessler Syndrome happen? The question is, how long can we keep being that lucky? Guys, I hope you found that interesting and maybe a little bit terrifying. If you did, thank you for your like, thank you for your hype, and thank you for sharing this video so people know what's going on. If you want to become a member of this channel for behind-the-scenes videos like seeing where I am when I'm using my Starlink, click the join button. And if you want to support the channel with coffee and fill me up, the link is in the description. Guys, stay safe. Enjoy the internet and the GPS on your car while it lasts. I see you soon. The clock is ticking. Bye-bye.